Saratoga. And so what do? I do a little bit of everything. I'm not saying I do any of them well, but I do a little bit of everything. I code in C++, Qt, and a few other different languages. I develop things, so in terms of creating new products, so I developed the first desktop simulators in dentistry that you see, and that now a lot of the companies are running behind trying to catch up with. I developed the portable simulators that get sent out to students on international master programs. I sell it, I move around, I sell the products, and I do presentations like this. So, well, the question is, what am I not? I'm not a dentist. I have done basic dental skills training. See me there on a phantom head, but I'm not a dentist. I'm not a full-time developer. I'm not the subject expert on that. Someone like Josh for the haptics who goes deep into one subject. But what am I? I guess what I love doing is two things. One is really pushing the frontier of what's possible with technology in education, and the other is I love making money. I mean, that's that's the truth of the matter. But a little bit of self-congratulations, I guess, just to myself, because this is really recent. So on Wednesday, the Prime Minister of the United Kingdom put me forward for an MBE, which is one of the highest honours we can get in the UK, a member of the British Empire. And on Saturday, King Charles signed off on it, and I got my letter saying I was on it. And that's really just for contributions to the technology sector. But yeah, it's very, very recent, like I said, it was literally Saturday. But what are we going to cover? So just some of the backgrounds, a little bit more depth, the haptics around what it is, what it does, and its limitations, where it is in teaching, and the challenges we have from a technology point of view as well. And so this is the first simulator. This is the Haptail project. It was really invented by one of my friends, Margaret Cox. And you'll see there it's quite rudimentary. We use mirrors for the 3D simulation. The haptics underneath, you'll see there as well. But this is all in all, we're coming up to 30 years of this actually being introduced into dentistry. When it was first looked at, so that's the research and development, 20 years of it actually in practice in the hands of dental students. And then you'll see where we're going at the moment. So this was Health Education England, which, like I said, Margaret Cox, Chris Luca, and a few other people were involved with. So this is really one of the first frontiers of it being not only, I guess, the universities that want to do it, but it being mandatory in some countries in the education so that it's fully embedded. And we have one of the ministers coming to see the technology on the 29th of June as well. And so there's two broad types of haptics. And it's important to understand because there's half of the simulators in dentistry that use one and half which use the other. Both have their advantages, both have their limitations. So you saw in Damiano's presentation, admittance haptics is the force you give then gives a position on the haptics, the force you get back and the feeling of it. So the way to try to understand it is that with admittance haptics, you turn on a simulator and the motors on the haptics start moving. And then it's already got a force there that's existing. So when you move it in free space, it's a little bit sluggish because there's already a weight there that exists. So it's really the way I think about it is that the haptics is a rock. It's already got its own force that exists. And when you touch it, if there was no difference to the haptics, you wouldn't be able to move it. So the sort of computational side of it is that you're pushing into the rock. And the rock's allowing you into it by changing the force on the motors that are already there. The advantage of this, which I think is not actually used in dentistry and it should be, is that the haptics can control itself. Because the motors are already running, the force is already there, and the sort of benefit that is used today is that the calibration in 3D space can be done by the haptics. So you just leave it, and the haptics moves in all the different directions, and it does a calibration, which is amazing. One of the advantages which isn't used, like I say, is that moving around, and which is something we're looking at now, is that you've got an expert like Damiano here, who, if you scanned it, you see the tens and tens and tens of research papers that have gone out. All of that knowledge isn't only what's in the paper, but it's the experience from real life. So it's Damiano's dexterity and motor skills as he's actually giving a treatment in microendodontics that few people have that level of experience. And you can't learn that from the papers that you're reading. So one of the advantages of this type of haptics is that in the future, we'll be able to ask Damiano to do a microendodontic treatment when the virtual side of it's good enough and record all of those movements. So today we can in VertiZ record the movement, but in the future, the hope is that as a student, you can actually go on, hold the haptics, and the haptics will move you in the same positions that Damiano's done during the treatment. So you can learn some of that dexterity, some of those motor skills, by physically just following it multiple times for the same treatment. A little bit like when you play a racing game, you have that sort of ghost that's that perfect F1 driver that we all try to follow and we fail. But this one will allow you to actually be that ghost and feel like what it's like to be the expert already from day one, which is incredible. But like I say, we're not there yet, but the possibilities there. Now on the flip side, you've got impedance. So it's the other way around. It's your position that's given into it that then gives a force back. So before we said when we turn the simulator on, these motors, they've already started, it's a little bit sluggish to move. This is the opposite. The motors haven't started running when you turn the simulator on. And the benefit of that is that when you move it in free space, it's completely natural, because there's no force there that exists already to then do the computation to then feed back to you. So it feels really realistic when we're in free space. And the way I think of it is, it's like walking through water. Like water, there's no real force there that exists already. It's not like a rock, you hit it and you can't move. So it's as you're moving in that water, the water is then pushing back on you. And you feel that force. You can't run in water as quick as you can on land. We all know that. And that's what's happening with the haptics. And the question is, eventually, when the feedback loop's so quick, will there actually be a difference between the two? Today there is. Today there definitely is. And so this was used in sort of these pro simulators on the left, these desktop simulators, these portable simulators, some of which you'll get to try tomorrow. And so some of the reasons we use it in is to reduce the cost involved, and then to increase the amount of practice that can be done on them. So there's various research papers showing like what is the cost we need to get to for this to be beneficial. Because today, most of these simulators are really expensive, which then means it's only the best universities in the world, like Boston, that would then be looking at them to do it. So with the desktop simulator that we designed, the portable simulator, it's all about bringing the cost down whilst trying to keep the haptics as realistic as possible. And if any of you are interested, Patricio's here from Saratoga, the owner, and we're working on a blended unit, which is then to hit that sweet spot between having the return on the investment that the university makes to the actual training capability of it. And so you've already seen the case study in Torino in Italy, so I won't bore you too much. And I don't know if you saw this video already. Great. So you saw what it's like in Damiano's center. And this is really the sort of sweet spot of what we need to try and do, is matching it up with the curriculum and what you get trained already, the actual evaluation as well, which is a huge piece at the moment, and then keep advancing on the technological side so we can get further to those things that I was talking about earlier. And the educational evaluation is really interesting. So we're starting to have exams on these simulators that are validated by universities, what they actually do, and then having controlled studies between both of them. And so that's the pro simulator. You'll get a version of it tomorrow. In the pack where you go on the drive, you can download everything. I've included a full video of the training that you'll see that we do on a full simulator. I won't bore you with a 10-minute video now. But this I did want to show. This is sort of where we're going to at the moment with virtuality. Some of the videos you saw on Damiano's presentation just there. It's about what can we do that's more than what we do already. Because if the simulators are more expensive than a traditional Phantom head, why create a digital Phantom head? I mean, that's the key of it. So we're starting to go down that route of patient interaction and trying to learn things that you'd only learn by being next to a real patient. So the feeling of what it's like to do a treatment when you've got a breathing patient and you can see the rib cage, and if they're not under anaesthetic, when they're sort of turning their head, or a child that's a little bit panicky. And here we've got the positioning of the patient's chair, asking the patient to move their head, and various things like changing the lighting, which we don't always think about as well. And when we consider these things, we often consider them as different avenues. We consider them as, what can we teach in virtuality with a headset on? What can you teach with haptics? But the question is, what can we do when we combine all of those at the same time? And so this is that patient-clinic interaction, that you've got a virtual reality headset on. When you move your head, it moves your actual position, your point of view. But also getting rid of things like the controllers, so that we actually visualize our hands within the simulation. And again, like we were talking about when you have that F1 game and you're following the ghost, actually tracking the hands and the things that the practitioners, the ones who are experts, don't even realize they're doing. So they can't even tell you about it because they don't realize they're doing it, and you wouldn't be able to pick it up until you have that same amount of hours of treatment. And so there's a whole host of academic papers out there. I'll put a link inside the folder as well, so we have a database of them, so they're nice and easy to find, and you can actually choose them by the type of haptics it is, admittance, impedance. You can choose it by the type of simulator it is, etc. So it's a little bit easier than scrolling online. So I hope that's given you a little bit of a bit more information on haptics, on simulators, what's possible, what's not, and hopefully what's possible in the future. So thanks very much. I don't know if you have any questions, by the way, before I take the mic.
Tomorrow during the workshop, I think that when you are using it, maybe some question will come out and better for you. Sally, I don't know. I try to write it, but if you want.
Yeah. Without mic. Is everyone listening to me, hearing well? Okay. But since everybody was mentioning this morning, I'd just like to say hi to all of you, and thanks especially to Professor Damiano Pasqualini, Dr. Samichonke, to let us co-support this event. I want to just report to you a few important topics, because last week we were attending the Italian Dental Deans Association yearly assembly, and the main topic was about AI and how AI is shaping a new dentistry, digital dentistry. And a few weeks ago, I was literally impressed by my little princess Victoria. She's only 2.5 years old. That she learned by mimicking her mother how to talk to Google and to play cartoons, bypassing all the different passwords that we set to let her avoid, to be overexposed to mobile phone. This is a clear indication where our world is going. Okay, so everybody was discussing about working together, because AI is all around us. I want to say when I do my presentation that, well, Siri, but well, Amazon is the biggest giant in the world just by leveraging AI to learn and understand how we are thinking. The latest algorithm by Amazon is start packing the stuff when a user is moving the mouse by 5 times on the same place. Can you imagine? Even before you click on order or process payment. In dentistry, AI is one of the greatest revolution ever, after the combine, after the zero scanner. And I think that event like this is what is really necessary to bridge the gap between the academy, between schools, between you, because you are the user of these technologies, and the industry. So we as Saratoga, as Vertisi, as 3D System, with the US manufacturer of the haptic arm, are willing to contribute with many other research projects about posture, for example. We created the very first AI algorithm to detect instantly student posture and give immediate feedback about eventually predicting the student cognitive skills. Some of them are just at the validation stage, because soon after COVID, I attended a course at Columbia University about AI for Business, and our mentor always reminded us, look guys, now technology is booming, AI is widely available, but what is really critical is to fine-tune the algorithm, to check what you feed in, because what you feed in is what you get out. So, thanks to all of you for attending the lecture. We wait for you tomorrow, because tomorrow you're going to try and practice, okay? And your feedback is extremely important to us, because based on your feedback, we can keep working on building consistent technologies and helping the academic community to integrate our technology that then, at the end, will let you deliver a better oral care. Because we just remember that our end result are the patient that you can treat every single day in your profession. Thanks again, and enjoy the pizza for whoever hasn't finished yet. Bye.
Hey guys, if you have any question, we are here. Otherwise, I think you are free to go.
We see you tomorrow.
I see the schedule. The majority of you will be again here. And so, according to the schedule.